So for 2, this is what we have. So our next function or our next implementation should be able to cater for 1, 0, and 2. Anyone willing to take this up before we do a random? Tracy, do your thing.
Random.
Yeah.
So random pick, occurred.
Okot has just gone missing. He's taking a call outside.
Okay.
Yeah.
Blue texo.
Oh, my turn again.
Yes.
Okay. We're at the less than 2. Okay. Or factor number 2. So a factorial is defined as this n times a factorial of n minus 1. So I think we should remove this when clause and instead keep just the get factorial n and let it return n times get factorial n minus 1. Because factorial 1, but however, this still requires for us to have the original one, that one that was matching 0, because when we run this, we minus 1 until we reach 0, and when we reach 0, we would get into negative numbers, which we don't want to. So yeah, there should be the 2 get factorial functions, one for this n, like we have it right now, and there should be another one saying that for 0, it is 1. And I hope that then it should work. Hopefully.
So we should have 2 get factorial functions, one that takes 0, which is our base. Okay.
Because then for 0, it will be 1. That's like fine. For 1, it will be 1 times 1, which is still 1, which is correct. And for 2, it would be 2 times 1 times 1, which is 2, which is also correct.
And how do we know that we have reached 0? Because I think we must also check for that.
If we have the second get factorial function that would accept only 0 instead of n, then we would know that we reach 0 because the pattern matching would pick the 0 function whenever we have 0. But there is because of the pattern matching, because it happens from top to bottom, this get factorial 0 should be above, like the first one should be this, I guess.
Get you're not sharing your screen.
Oh, it broke, but oh yeah, we see it again.
I'm sorry, we dropped off for a bit. The internet kicked us out. Okay, I might have missed the better part of what Blutexo said. Sorry.
Okay, so I'll repeat my last statement. You asked how do we know that or how does Elixir know that we reached 0? And if we have another function that matches 0, then that's exactly it. Like it would try to match 0, and if it works, then great. We know that we reached 0, and if not, then we will do another iteration. So. And I see. Still, there is there is n times n minus 1, but there should be n times get factorial n minus 1. That's the missing part here.
Okay.
And do you think we should keep the state of the previous?
Oh, Yeah, we should restore the previous one, and it should be put above this one, because the matching goes from top to bottom. So otherwise, it would try to match. Even the 0 would be matched with this n, because even 0 can be and some n. But if we put the get factorial with 0 above, then this would be first one that would be tried. And if there's 0, it would try this get factorial 0, it would match, and it would never get to this one, which we want to reserve only for non-zero values. So let's try it.
All right. So we have another function close for 0.
Yeah.
And it must be at the top.
Oh, at the
like,
top.
Above.
Got it. Okay, so get factorial. Wow. Zero. Okay, so whenever it gets 0, it should return 1.
Yeah.
Okay.
And this should be it.
Wow, looks neat.
I also think we should add an accumulator.
An accumulator, what's that for, Tracy?
Okay, for example, we are supposed to get, we are working with a factorial of 2, right?
Yes.
The factorial of 2 returns 2. Let me take another number. The factorial of 3.
Yes.
Factorial of 3 is 6.
Yes.
Okay, so let's go back to the function implementation. So we are working with 3. So in the first, when you pass 3, it will match the second function, get factorial.
Yes.
Then we'll do 3 times get factorial n minus 1.
Which is 2 times.
2. Okay, we have a recursive function.
Yeah.
Someone's machine will hang.
If you pass in 3, it
Be
would
ready
be
for
3
freezing.
times a factorial of 2.
Yeah.
Pardon?
If you pass in 3, then it's 3 times a factorial of 2, which means 3 times 2 times 1 times 1.
Will it talk?
Yes. Sure.
Okay,
Yeah.
we can try that.
Okay. I hope it works as good as it looks.
Yeah, imagine if we're going to have an endless loop.
Only one way to find out.
We would have one if there wouldn't be the first function with 0. But because n minus 1 would eventually always get to 0, then this get factorial 0 would break this endless loop, because like it only returns value and doesn't do recursion.
Yes. Does that make sense, Tracy?
Okay.
Or before we get
still in doubt if it will return the final answer. If it's
Sure.
3, if it will return 6. But we try first, then we see.
All right, we could do a rerun of what it does on the background before we run it, right?
Yeah, good idea.
So we get an understanding. So on the very first iteration, we pass to, I'm just going to abbreviate it to GF. That's the get factorial method. So we pass 3, right?
Yeah.
So what happens is it's going to match the second clause, which is get factorial that takes n and not 0, this one. Right? So at this point, we have n, which is 3, times
get factorial.
Yes, times, come on.
Edit.
It's okay. Times get factorial of 3 minus 1, which in this case is 2. Right? So we're going through the same process, but with 2 in this case. Make sense? So we're going to get factorial with 2, and it's going to land on the second one again. So it's going to be n. In our case, n right now is 2, right? Times 2 minus 1. In our case is 1, right? The GF of 1.
Yeah.
Then we go through the cycle again. So in this case, it's still going to meet the second clause because we're not getting a 0, right? We're still together, Tracy?
Yes.
Okay, so our n in this case is 1. So we do 1 times GF of
0.
Of 0. We run the GF of 0, and in this case, it's going to match the first function clause, this one. So in this case, we get 1.
So will our function return 1?
Not really. So we have to evaluate this from the innerst, the innerst function going outwards. So in this case, we have, let me look for another text box. Sorry. So in this case, we have the GF with 0 is 1, right?
Yeah.
Let's put that in brackets. 1. The GF of 0 is 1. And this one is times, I'm trying to go backwards, times 1 again, right? Also going backwards, times
2.
2. We go back again, times
3.
times 3. So basically, this is what's happening.
But how does it know the states, the previous states?
I don't think we need to keep track of the previous states.
Because I don't think if the stack is there and if it will know what value to return. Because remember, Elixir returns the last value evaluated.
So in this case, the last value being evaluated is a recursive function. So it will have to evaluate the recursive function and then return the last thing, which is this, n times whatever the recursive function has returned.
But remember, our last n will be 0.
Our last n will not be 0, it will be 1.
It will be 1.
Yes, and then it calls get factorial with the 0.
Okay. May think it will return 1, but you can try first.
For sure. Okay, so we call factorial, sorry, get factorial. So we can start with 0 first.
Yeah.
So what do we expect? We expect 1. Okay, great. So now we call it with 1. What do we expect?
1.
Yes. And now we call it with 2. What do we expect in this case?
I expect 1.
Thank you. Okay. We have 2. So when we call it 3, I'm pretty sure Tracy expects 1, but we should have 6.
Oh.
Great. Yes. Now, does it make sense now?
Yes. So it's
Okay. Are you sure? So how? Okay. Sawa. Yeah, it seems weird because of the recursion. In our naked eye, we can't quite see what's happening behind the recursion.
True.
But when you follow through, this will all make sense.
But this means we're working with linear recursion.
Linear recursion.
Do you remember the Lisp book that we used?
Sorry, do I remember what?
The Lisp Lisp book that we used to go through.
The list. Oh, yeah. What was the name of that book?
Something MIT.
Yeah, MIT, yeah, yes. I remember when it was talking about iteration and recursion and trying to put a difference between the two.
Yeah. The iteration
Okay.
whereby you evaluate till the end, then there's the recursion whereby we expect to keep state.
Yeah. At what point do we keep state? I'm looking for a scenario that we need to actually have an accumulator. Um, Anyone with any insights on this? It's okay. We can do a mini session before we begin our next session next week.
Mm-hmm.
Just a brief session on this, just to see when exactly we need to keep state of the previous.
Of the previous value.
Yeah, but take for example, when we're doing a function like sorting, you remember when we did the recursive function for sort? So when you're sorting, you actually need to keep track of the previous number or the previous value because you're comparing two numbers or you're comparing two integers. So if you don't know what you're comparing it to, that could be a little difficult. So in that case, we keep an accumulator. But in this case, it's just a matter of evaluation, and whatever it gets, it returns.
Okay.
Yeah, but we can do our homework more and then talk about it next time. What do you think?
Yeah, we can discuss about this on how we can keep state.
Okay, great.
I would really love to see this implementation just be run through the Codewars test, like just try to submit it because I'm pretty positive that this should work already.
Great. Yeah, well, we're about to do that. Let's just do it.
It's only, I think the function needs to be named only factorial instead of get factorial, but that's only a
Yeah, true.
Okay. The rains just got upset here, but at least we're winding up. Alright, so I think it's get factorial instead of factorial. Right. Drum roll please. So let's test this.
I want to keep what?
Oh, sorry.
Something is missing.
No, it was
Oh, I see.
my fault.
I want to check out the time.
You see,
Great.
you see, I told you.
You wouldn't let us rest. Awesome. Virtual claps, Lutexo. Virtual claps. All right.
I'm happy to see it. Thank you for submitting that.
Yeah, this has been awesome.
Yes. You just helped me rank up to 7K. Thank you. All
Okay, I
right.
think we are
Yeah, go on, Tracy.
okay. We have like 2 minutes left. I think we can wind up from here, right?
Yes, this was fun. Thank you.
Yeah, this was fun. See you next Monday. Bye.
You see ya.
Bye.